Hello everyone, can you hear me now? Hello everyone, can you hear me? Any sticker emoji you can
Yes,
on.
please.
Yes,
We can
please.
hear
We can
you.
hear you.
So I don't want us to waste much time, okay? But there are some things that I would like to tell you that how should I put it? That I won't during the class. So if you have friends that you think they would be interested, please call them so they join. Okay. I'm not just come to solve questions, it's far from that. Okay. So please, if you have the link, you can share it. And I've also shared a document to my TMM group, my Teach Me Maths group. Okay. So that's one thing that we would be using. I'll be taking you through last semester's IE, not the answers, but some technicalities that you should take note of. Okay. So the numbers are not encouraging. I'm expecting a lot of people. So please invite them. Okay. So we'll be starting in just 2 minutes. Okay. So 7:17 then we will be starting. Okay. So please invite your friends. Hello, please can you see my board? Can you see my board? Can you see my board? I'm
Yes,
sharing
sir.
my board. Can you
Yes,
see my board?
please.
So I have shared I have shared a document in the in my group. Okay, so if you are in my group, you can check it out. That's what we will be using for today. Okay, so So I've shared a document. You can check that out. But if let me try and import my document so that we can use it. One minute. One minute. Okay, so let's pray. Father, we thank you for this opportunity. We thank you for the opportunity to come before your presence and study. It is our prayer, O Lord, that as we prepare for our exam, you grant us the understanding, you grant us the retentive memory to study and pass in your name. In the name of Jesus, we pray with thanksgiving. Amen. So, I tried sharing and using the Blackboard available, but I couldn't. Okay, so I think I'll go back to the way I do it. So so the first thing I'll be taking you through is the last year's I. Okay, so before I take you through last year's I, let me make this statement. Okay, now the math exam is a peculiar exam. Every math exam is peculiar. Now, why do I say that? If the exam looks hard, okay, try and finish. Okay, try your best and finish. Even if you don't know it, write a formula, do something. Okay, don't leave any space blank. Okay, that is if the exam is hard. Two, if the exams look easy, everyone is asking for extra sheets. People are finishing before time, they are standing up. That means that take note of the procedure. When the exam is easy, don't joke with the procedure. Like take note of the procedure. You're like every single. I will share some marking schemes with you from previous years and previous papers. Okay, so you see that some of the questions, if you don't define the interval that is defined on, even if the interval is defined in the question, for example, you get a question and they say where x is greater than zero. Before you even start answering your question, you should also state that okay, the function this is the function where x is greater than zero. In one I think last test I that occurred in about two questions and they each carried a mark. So students were penalized twice. A lot of students were penalized twice. That's just one of them. So if the exams you think looks very simple, you see that the exams is simple, but the results come and people don't do well. It's because they don't take notes of their procedure. When the exams is very difficult, sometimes you are parting with the steps, okay, because people don't finish. So when it's easy, the steps. When it's hard, try and finish, okay. But don't leave anything blank. Now, this is last year's IE. Okay. So I shared a video in my TMM group, which I made 1 year ago, right? And I asked you to watch it. If you haven't, I'll reshare the link after then. You'll be able to do that. So this is the question. Okay. I'll be flipping. So if you are in my group, you can just open it and follow along. Okay. So this is the question you can take a screenshot of this. This is what we will be doing for I think 2 minutes. I don't want us to waste much time. Now, okay, so let me just use this. Now, the first question was that let me see the pencil here. Okay, let's get a pencil. Okay, so let's just do this visually. So that's f of zero So the question says that using the graph, find the following limits. Okay, that was the question. Okay, now f of zero, right? So f of zero, right? Let me write it down so that you visualize what I'm saying. So f of zero, right? That's the first one. The second one is f of two.
Hello,
The third one is here. Hello, hello. Can you hear me?
hello.
Yeah, hello. Can you hear me?
Yes, please. You can hear you. I can hear you.
Okay, okay. Thank you very much.
Yeah,
There was a guy saying
green.
hello, so I was asking, please mute your microphone too, so that I don't have to be going back to do that. Okay, please mute your microphones. Limit as x approaches zero of f of x, right? And finally, the limit as x approaches 3 of f of x. So now these are the three things that they were asked to find, and this carry 12 marks out of the 50 marks. Okay, so these are the three questions. Now, the first one is f of 0, right? That's find the following limits. So what is f of 0, right? Now you can see that there is a whole discontinuity at f of 0, right? If you were to find a limit as you approach f of 0, right, it can exist. But because of the discontinuity over there, f of 0 does not exist. So the answer they expected was x of 0 does not exist, right? Or simply does not exist. The second one was f of 2, right? F of 2. So now all you have to do is what we used to do in back in JHS. So we are starting with something very basic, okay? Then we would go higher, okay? So we will not be doing just fast questions today. Would be doing my personally selected questions after the past questions, okay? So please stay with me if you think this is kind of basic. So now f of 2. What is f of 2? This is simple, right? So where x is 2, what is the y value? Okay. So you just map it to the graph and map it onto the y-axis. So f of 2 is 0. Okay. Similarly, what is f of 3? Okay. F of 3. So now you try and map f of 3 to the graph, right? And you can see that there's nothing. Okay, so f of 3. Okay, so there's f of 3 is actually defined over here. Sorry. Yeah, f of 3 is actually defined over here. So we are seeing a dot over here, right? So f of 3 is defined. You can check the slides, okay? There are conventions, what the whole means, what the shaded whole means. Everything is in a slide, so you can look up that later. So this means that f of 3 is actually 3, okay? F of 3 is actually 3. I won't be using the technical terms, okay? So just bear with me. So now what is f of x as x approaches 0 from the left? Now look how we go about it. When f of x, right, approaches 0, right, from the left, right? So from the left, as we approach 0, right, as we approach 0, as we approach 0. So now this is the function that looks like it's approaching 0, okay? Now you can't use this one because this one is at the right hand side of 0, okay? So this one is approaching 0 from the right, okay? Because when if you are confused with the left and right stuff, when it's approaching from the left, it has a negative at the top. Okay. So on a normal number line, the negative should be at the left hand side and the positive at the right hand side. So when you see the limit as s approaches 0 from the left or with the negative, so you just take it from the left hand side. Okay. So now we can see that as f of x approaches 0 from the left, right? You have infinity, right? So this just goes on and on and on. So the answer for this question was negative infinity. Okay. Now, the second question was that the fifth question was that the limit of f of x as x approaches 0, right? The limit of f of x as x approaches 0. Now, what is that limit? Now, for you to find the limit of a function, right, there are some conditions that have to be satisfied. That is, the left hand limit, right, should exist. The right hand limit should exist. And finally, they should be equal. These are the three conditions that the limit should have to exist. Now, one thing that let me chip this in before I forget is that you should know the conditions for continuity, discontinuity of it. When you're asked to find to solve for continuity or discontinuity, you have to use all these three rules in your calculation. Okay. A question like this, you were not asked to state like the question was using the graph, find the following limits. Okay. Just two marks question, so you don't have to do much. But for most of the questions, you have to use all these three rules to show that the limit you actually know what you are doing. Okay. So now the limit of f of x as x approaches zero. Now the first thing that we should find is that does the left hand limit exist? If it does the right hand limit exist? If the right hand limit also exists, are they equal? Now, as f of x approaches zero from the left hand side, you see that we have negative infinity, right? The function approaches negative infinity. It just goes on and on and on, right? Now, as the function approaches zero from the left hand side, right? It's approaching zero, right? From the left hand side, right? So you can map zero to this and you get two, right? You get two for the function approaching zero from the right. Okay. So as it approaches zero from the right, the zero with the plus at the top, you get the function to be equal to two. But from the left, you get negative infinity. So when the limit at the left hand side is not equal to that of the right, the limit of f of x as x approaches zero does not exist. And that was the answer. Finally, the last question was that find the limit of f of x as x approaches 3, right? As x approaches 3, right? As x approaches 3. So this was the question that was asked. As x approaches 3, find the limit. Now, this looks tricky for you to say that it exists or conjure your value for it or something. Okay. Now, if you've done okay, so to explain how should I put it? To explain continuity, right? Remember that earlier in lecture one, they say that if you can draw a function, right, and you don't raise your pen or your something, like you draw a function without raising your pen, then you can say it's continuous. Exactly. So now you can see that this is three, right? This is three. As you approach three from the left, this is the function when you are approaching three from the left, right? Hello, can you hear me? It's like the class is too quiet. Can you hear me? Can you hear me, please? Can you hear me?
Yes, sir.
Yeah, let's
Yes, sir.
start.
Yes, sir.
Yeah,
So
yes,
if you
but
can
Yes,
hear
please.
me,
it's just that your voice is a little bit far.
it's a little bit far. Is it
Yes,
low or
yes, I can't quite
low
hear you.
or
I've checked all my
okay?
machine
Is it
there.
the
Mhm.
is is it the only one or we all have that problem so that I change my device? Is it the only one,
Sir,
please?
sir, no,
We,
no.
You can all hear me
Yeah.
clearly.
Yeah, I can hear you, but it's a bit muffled.
It's a bit muffled. Hey, your English is good. Calm down for me. Okay, so I'll try and
Yeah,
speak louder. Can you hear me now? Can you hear me now? Can you hear me better now?
it's better now. Yes.
Okay, sure, sure. Let me raise my voice. So yes. So now this is the function that approaches three right from the left. Okay, it's approaching three from the left. So the value of this, so you come from the left hand side of three, you move and you see that it maps onto one. Okay, so approaching three from the left, right, you get one. Do you see it? Now approaching three from the right hand side, you approach three from the right hand side. And when you get to the point that you are exactly on top of three, you map it onto the y-axis, which you get two. So because the left hand and the right hand limit are not the same, the answer is two. Now, the reason why I wanted to go over this kind of question, even though I've asked you to watch the video, which most of you haven't, and you've not even subscribed to my channel, is that this question has come in a lot of past questions, okay? And the performance was average, so maybe, just maybe, they can bring this, okay? So this for the first part. If you are new and you just joined us, I've shared the documents I'm using to my TMM group, okay? So you can check it and follow, okay? And we are doing Pascal for the next 30 minutes. Then we go to the questions that I've selected, okay? So now the second question is
Sir,
that
please,
for the
question.
given function, yeah, question. Yeah,
Sir, please,
this
can
has
you go back to the graph? Sir, please, you were like, the limit as s approaches 3, which is
yeah.
the black dotted, the shaded part there. So please, when you trace it to the y-axis, isn't it a little bit above the 3 there, approaching the next something, the next number, which is 4, or is it because of how they located the points there?
Yeah, oh yeah, this one is not done to scale, so you just approximate it to three, okay?
So me, I was
Okay.
thinking it was approaching 4, since it's a little
Oh
bit
no,
above the
oh,
3.
no, 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 no. I'm sure maybe the angle at which I took the picture, okay? Yeah,
Oh, okay, okay.
yeah, the angle. I'm sure it's the angle. Okay, but it's three. Okay. So now this is the second question of the IE. Okay, this is the second question, and let me tell you something. This IE
Um,
was very
please
easy,
ask a
very,
question,
very,
please.
very simple. Yeah, please ask your question.
Uh, please, this thing you said, Pascal, you said you will solve. So after that, will you send the Pascal to the group, or as maybe some of the who are not able to join the class?
I think I'm recording the lecture. Okay, I haven't recorded it
Okay,
using things before, but I'm recording. So after I'll try and share it. Okay, okay.
okay.
Yeah, so I'll do so. But the document is in my TMM group. Those who are in my TMM group, you have access to it. Okay.
Thank
So now this is the second question. For the given function f of x below, determine whether or not the following exists. Okay. So I like you all to. I don't want to open my WhatsApp chat. Let me see. Okay. So this is my TMM group. Okay. I've shared the document. This is the document. So you can go and download it and follow along. Okay. Because I'll be switching to my blackboard. So for the function f of x, we'll determine whether or not the following exists. Okay. Now I'll come back to something I said earlier. Okay. Remember I said that if you are told to find what's the question? To find if a limit exists. Now ask yourself that what are they asking you? What do they want to test you on? Okay. They are trying to test whether you actually know the rules for a limit to exist. Once you know this, you know that okay, in my solution, I'll make it clear, right? That I know the conditions for the limit to exist. Okay, because it's easy to solve and get the answer and not state clearly what the conditions for the limits to exist are. Okay, hope I'm making sense. Yes. So now let's see. I've answered myself. That's fine. Let me clear this and let's continue. Let me see. Okay. So now the first question was that the limit. Sure if the limit is so. Let me try and write everything. The f of x is equal to like a piecewise function which is defined as 0 if x is less or equal to negative 5. 25 minus x squared if negative 5 is less than x, less than 5. And finally, 3x, right? If x is greater or equal to 5. Okay. So now the first question I was that the limit of f of x as x approaches 5. Okay. Now, as I said earlier, they are trying to test whether you know the conditions for a limit to exist. Okay. Now, what is the first thing you have to do? You just have to show that the left and right limit exist and that they are equal. Hope you get me. Now, you before you start, you have to say that for the limit f of x to exist, the limit as s approaches 5 from the left should be equal to the should exist, and also right should exist, and they should be equal. Please do get me. So something like that, you can state it mathematically. Okay. So I won't do that. Okay, because I think that will take our time. Okay. So you find the limit as x approaches 5 from the left. So the limit as f of x of f of x approaches, what is it? Sorry. So x approaches 5, right? From the left. Okay. So now from this piecewise function, right? Which of them shows that x is approaching 5 from the left? Okay. Now you can see it's 0, right? If x is less or equal to negative 5. Okay. So this means that it's 0 if x is less or equal to negative 5, negative 6, negative 7 going, right? So as x approaches 5 from the left hand side of negative 5, which is negative 6 going downwards. Hope you get me. Right? So this is the one that we are going to use for um the left hand side of 5. Okay. 5 from the left. Okay. So from the right also, right, which is um numbers above negative 5. You have your graph here, right? You have um negative 5 to be somewhere. Let's take negative 5 to somewhere here, right? So approaching negative 5 from the left in this case, you're approaching negative 5 from this side, okay? And you know that at this left hand side, you have negative 6, negative 7 going, right? So from the right, of course, you have 6, 7, 8, 9, 10. You get, sorry, you have negative 4, negative 6, negative 2 going, okay? Now, we can see clearly that this is defined, this shows that it includes negative 5, negative 6, negative 7 going. And this, of course, includes numbers greater than negative 5 to positive 5. Okay. And this includes numbers that are greater or equal to 5. Okay. So I've explained that. So let's just get to the solution. Please don't focus on my solution. Okay. The solution is more important. If you can get the concept behind what I'm doing, I would be very happy. Okay. So now, approaching 5, right, from the left hand side, right, it has already been given that the limit of f of x as x approaches 5 from the left hand side is equal to 0, right? It's defined over here, right? Now, the limit of f of x as x approaches 5, right? From the right, okay. So we are using this one. I just explained why we are using this one. If you don't get it, you can still unmute and speak. But I hope everyone gets me, though, right? You have what? So all you have to do is just insert the 5 inside, right? I use negative 5 for the example, but it's actually 5, okay? So the left hand side of 5, okay? Wait, let me check the question again. I think the question is, okay, so the question is 5, okay, 5, yes. The first one is 5. Yeah, the first one is 5, okay, yes. So, okay. I'm coming 1 minute. Okay. So I've seen where the error came from. I I did an error. Okay. So now the question was that find the limit of f of x as x approaches 5. Okay. So we are using the left hand side of 5 and the right hand side of 5. Okay. So what we used was negative 5. Okay. So we can so this is not equal to 0. Okay. This is not equal to 0. I hope I don't confuse you. Please stop. So we have to use the 5 instead of the negative 5 as I did earlier. Okay. Apologies for the mistake. So now the left hand side of 5. Okay. So now the left hand side of 5 is of course 4, 3, 2 going downwards. Okay. So we are going to use this equation. Please, do you all get why we are using this equation for that? I know I swapped the bar, I extended it to a point. Please, do you all get why we are using this equation for the left hand side of 5? Okay.
Yes, sir.
So now okay, sure, thank you very much. So all we have to do, right, is insert the 5 into this equation. Okay. So we get 25, right? 25 minus 25, which is 5 squared. Okay. And this gives us 0. Okay. Now we also have to find the limit of f of x as x approaches 5 from the right. Okay. So from the right, as I explained earlier, you have the graph. 5 is somewhere here. From the right hand side of 5, right? So coming from this direction, okay. So which is 6, 7, 8, 9, 10 going, okay. So from this, you can see that from this equation, right, is defined it has a range which includes the values being greater than 5. Okay. I know it's range. Okay. It has values greater than 5. Okay. Because we have to find the value of the function when we are coming from the right hand side of 5. Okay. So of course we have to use this equation. Okay. If you don't get what I'm saying, you can just unmute and speak at any point. Okay. It's totally allowed. So the function we are going to use is 3x. Okay, 3x. All we have to do is to insert the 5 inside and insert the 5 inside, right? So we get 3 times 5, which is of course 15. So from this, we can see that when we approach the function, when we approach the function, when we approach f, right? When we approach 5, right? From the left hand side, we get 0. Okay. Now, when we approach 5 from the right hand side, we get 15. Now, the question was that find if f of x exists. If you don't know that a condition for the limits to exist is the left and right hand side must be equal, you get this question wrong. Okay. So you can come and conclude that since the left hand limit is not equal to the right hand limit, the limit does not exist. And the way the question will be framed, if you don't take a careful look, you'll not even have the idea that you have to test the right and left hand limit. Like you have to know this okay, okay. So I will not solve um the which is that the limit as x approaches negative 5, right, of x. So show that this limit exists. If you are able to solve this, you can come to my DM and show it to me. Or if you have any challenge, you can show it to me, okay, so that I confirm, especially your steps, okay. So now we are going to move on quickly to the next question. I want us to do a lot of things today. I don't think we are halfway through. So you are done with this one. Okay. Now, if you are in my TMM group, I said something earlier that you should solve every question in your slides, in your exercises, because more than half of the questions that you might be solving tomorrow are coming from a slide. Like that's the format. A question like this is in the exercise. I don't know the number of you that have and that. So I think this same question, yes. It's in the exercise or that's one of the exercises. And this question was just lifted and brought. So if you have solved this before and you have the concept in your head, it's quite simple. Okay. Now the question was that explain why g of x is discontinuous at x is equal to 4. Okay. Why g of x is discontinuous at x is equal to 4. Now, what's the condition for g of x to be discontinuous? Okay. You have to put those conditions down if you don't know them off it. Okay. So now let's solve this. So at x is equal to 4. Okay. At x is equal to 4. So now let's try and find the limit, right, as x approaches 4 because they are telling us that it's not continuous. Okay. So we have to find the limit as x approaches 4 and see the value we get when x is actually approaching 4. Then we can make our deductions from that. Okay. Um, so now let me clear this. Now, if you are not getting the discontinuity limit in and whatever, now get it this way. For a function to be continuous, right? For a function to be continuous, it has three conditions. Okay. The left hand limit should exist. The right hand limit should exist. Right? And they should be equal. Right? So if you are asked to explain why g of x is discontinuous at x is equal to 4, then they are telling you that at x is equal to 4, like how should I input? Let me not use. If either the left hand limit does not exist, the right hand does not exist, which will make the limits not exist, or there's something wrong. Okay, there's something wrong. And also the final condition for a limit to be continuous, right, is that the limit of the function, right, at that point. So this is the condition, the final condition for the limit to exist. I will not go through all the conditions. Okay, they are in your slide. Okay, so the limit of the function at that point, let's say a, right, should be equal to the function at that point. Okay, so these are the conditions for the limit to exist. And you know that for this to exist, right, the left right should be equal to exist and they should be equal to each other. Okay. I know I'm speaking too much, but I want some of you to really get the concept. Okay. So now we are asked to explain why it is discontinuous at 4. We have g of x, right, which is equal to x squared minus 2x minus 8, right? If x is not equal to 8, sorry, if x is not equal to 4, right? And 3, if x is equal to 4. Okay. Now this is the question. Okay. Now, why is x discontinuous as x is equal to 4? So we are going to find a limit, right? The limit of g of x, right? As x approaches 4. Please mute your microphone. Okay, mute your microphone. Okay. Now, so we are finding a limit. Okay. I don't think there's a explanation. So we just insert our values then. So x squared. So this has a denominator actually x minus 4. 2x, right, minus 8 on x minus 4. Now we know that we can factorize. Okay, I'm not going to go to how to factorize. I think you can do that with the calculator. So you get, I think, x minus 4 multiplying x plus x plus 2. Okay, all on x minus 4. Okay, and from this you can see that we can cancel out. Okay. If you watch um organic chemistry tutor, you say that this is a discontinuity at x is equal to 4, but it's called a removable discontinuity. Like you can watch that video and get more on this. Why it cancels out. Okay, it means something. Okay. So now you get the limit as x approaches 4, right? Of x plus 2. You just input in your values and you get 6. Okay. So now you know that the limit as x approaches 4 is equal to 6. Okay. And now from the question that we had, right, we've been told that at g, sorry, okay, yes, is g here is at g of 4, right? The function is equal to 3. Okay. So at g of 4, the function is equal to 3. Okay. Now from your calculation, right, you got that the limit as x approaches 4, right, of g of x, right, is equal to 6. Now, because these two are not the same, right, you conclude that g of x is discontinuous at x is equal to 4. Okay. Now, the second question that was asked was that redefine the function so that it is continuous on R or everywhere. Okay. So how can you redefine it so that it actually becomes continuous? Now it's simple. Now you can simply say that for the limits to be continuous, right? G for the limits to be continuous, right? And for the limit g of x to be continuous, right? As x approaches 4, right? It should be equal to 6 as you saw. Okay. And you are being asked to redefine your function, right? So you can also state that, and also g of 4, right? Um, it should be equal to 6. Okay. So all you're trying to say is that, okay, for my for my um for my function to be continuous, right? The limit this should be equal to this. Okay. And you know that when you solve for the limit, you got 6. Okay. Now all you have to do is that you are telling them that, okay, you are telling them that this is equal to 4. But for them to for the limit for the function to be continuous, right? I have to make this 6. Okay. That's all you are saying over here. So that's what you do when you have to redefine a function. You can read more on this on ChatGPT so that you really get what I'm saying. Okay. There are deeper concepts to everything you are doing here. When you really get a concept, like it gets easier
Say,
to really understand. Yeah, hello.
say, please,
Yeah,
can
hello.
you go back? So please,
Yeah.
can you go back?
To the
Yes, please. So say, when you say we should redefine it, can you also say that g of x equals the parenthesis, then you put in place of the x square minus 2x minus total over x minus 4, you put x plus 2 if
yes,
x equals 6, and the
yeah,
down part you do it 3 where x
yeah,
equals 4. Can you leave it like that?
yeah. That's actually the right approach to do to get all the marks. Okay. So this what you've done. Okay, this one is also correct, but what he's saying is actually even better. Okay. So all he's saying is that you actually rewrite this again. Okay. But instead of the 3 that you've been given there, you write 6. Okay. So yes, thank you very much for that. Thank you very, very, very much. Just hope you all get what I'm saying. Hope you all get me, please. So we are moving on to the next question. Thank you very much. Thank you very much. I really appreciate that. Okay. So the next question is that find the limit of f of x as x approaches infinity for all x greater than 3. Okay. For all x greater than 3. So I'll be solving more questions, no, taking you through more questions. So your friends that are annoying, please, you can please like send them an invite or something. Okay. Now, a question like this, I would like you to take note of it. Now, okay, let me write the question, then we solve them together. Okay, let me write the question and solve it together. Now, let me see. The question says that so 4x minus 1 on x, right, is less than f of x is less than 4x squared plus 3x on x squared. Okay. Now you are being asked to find the limit of f of x, right, as x approaches infinity. Okay. Now this you are looking at here, right, is a squeeze theorem. Now one thing that I would like you to take note of the squeeze theorem is that it will be very rare that you'll be given a question and you'll be told to use squeeze theorem to solve it. Often you will not be told to use squeeze theorem to do anything. And if you're not familiar with most of the questions, you will not even know that a squeeze theorem that you are being asked, a squeeze theorem that you are asked to use. Okay. So this question is actually a squeeze theorem typical question. Okay. Yes. So we are going to solve this. Okay. I don't think I should take you through this question. Okay. So you can solve this. Okay, using the squeeze theorem. Let me just write how you are going to go about it. So you just take the limit as s approaches infinity on both sides. Okay. Then you get the answer. Okay. So the answer is 4. Okay. Yes, I remember the answer is 4. So you can solve this and get back to me. Okay. No, I think I should solve it for this. Let me just solve this. So now you can break this down, okay, which gives you 4, which is equal to 1 on x. Okay. And this is how I'm solving mine. Okay. So you can solve yours in your way. Okay. So 3 on x. Okay. Now you are being asked to find a limit as x approaches infinity of f of x. Okay. So you take the limit as x approaches infinity on both sides, right? Limit as x approaches infinity on both sides. Now with this, you get 4, right? Minus 0, okay, which is less than the limit as x approaches infinity of f of x. Please, I'm jumping some steps, okay. So, but if you are doing it in your exam, um, please like show all steps, okay. So now you have 4 is less than the limit of f of x as x approaches infinity is equal to 4. Now let me try and explain why you come and conclude that the limit of f of x as x approaches infinity is also equal to 4. Now, how should I? Okay, so now having a straight line, right? Having a straight line, right? Having a straight. Okay, you are on a road actually. Let me use this example. You are on a road actually, right? And you are moving from this distance, from the distance A to the distance B, right? Now, there you are being told that how should I put? Okay, you are being told that um okay here. So A and B is USA. Okay. A and B is USA. USA. Definitely, if you are anywhere between A and B, you'll be in USA. So that's what this the squeeze theorem is about. If the extreme values are a particular value, anything in between also, right, should also be that value. That's the basic concept behind the squeeze theorem. You can check the derivation. It's actually fun. Okay. Then you get some more. Okay. Don't say this. So let's go to our next question. Let's go to our next question. Let me see. Let me see. Let me see. Let me see. So should I solve this? Okay. So let me solve the first one. Let's go back
Sir,
to.
please, can I ask a question?
Oh yes, please. You can ask the question.
Sir, please, on the squeeze theorem for let's say trig functions, is it are we always advised to use the -1 less than x, sorry, less than, let's say for sine or cos, less than 1 always, or there is another way we can do,
Okay, so
we can go about?
okay, okay, let me use. There's one question that we would be solving, isn't that so? But let me just explain it to you before we move on. Now, if you've seen the sine graph before, right? The sine graph before, it oscillates between -1 and 1. Okay, or am I? Is it? Yes, I think it's -1 and 1.
Yes, yes, yes.
It's something like the two. I just extend it so that it becomes clearer. So if you've seen the sine graph, I haven't checked this in a while, but I think this was it. It looks something like this. It just moves to something like this. Here. So now in most trigonometric questions that you'll be asked to find the value of the sine function, right? They will not tell you to use this term as I said. So if you are finding the limit of a sine function, the maximum value that a sine function can give you is -1. Okay, sorry, is 1, and the minimum value is -1. So usually you define, you find the function when it's between like at max 1 and at min 1 and at max 1. So if these two gives you the same answer, then everything between that is that value. Okay. So that's basically there's one example that we would be solving, that we would be applying that. So don't worry.
Okay, sir.
So
Thank
I'd
you.
like to say this question is also in a slide. I think it's an exercise. So, okay. So the limit as x approaches to, okay, of f of x, right, is equal to 2. The limit as of g of x, right, as x approaches to, right, is equal to 5, right? And the limit as x approaches to of h of x is equal to 0. Now, find the limit if it exists I, right? So I'll do the I, then I'll leave the I for you to write on your own. You can come to my demonstration if you want. Yes, totally optional. So on g of x, okay. So this is actually quite simple. Okay, this is equal to 2 multiplying by this. Right? Sorry, let me finish the question. The limit as x approaches to, okay. So now you know that for you to find limits, right? Okay, let me show you something in this. See the way let me speak better English. The way I was doing actually, you can get less than half of the mark. Okay. What am I saying? So with something like this, right? Um, you are being given that find x find the as x approaches to. Okay. Now you have to show them that you know that when limits are adding, right, or when they are being divided actually, right, you can take the limit as x approaches to, right, of 2 of f of x, and you can also take the same limit of the other um what's the name, variable that is being added to it. You get yes. Also, you can also take the limit of the denominator. Okay, so this is actually a rule of the limits, which is in the slide. Okay, so a question like this might look simple, like the way I was solving, just slotting in the values. And look, I can get less than half of the mark if I do that. Okay. But because of time, I just want to explain this thing so that we move fast and so that we are able to cover a lot of stuff. Okay, so bear with me.
Sir,
So yeah,
sir, please won't the 2 attached to the f of x be at the left side of the limb as x approaches to, so that it becomes 2 limb x approaches to f of x?
yes. So you can also this is correct. Okay. You can also move the two at the other side. Okay. You can also move the two at the other. So what he's saying is that you can. Why aren't I doing it this way? Two limb to the limit of f of x. Yes, this was his accent. Yes, you can also do this. You can further on move it over the bar. Okay, so let me just do it this way. So this right. So you multiply the limit of f of x as x approaches to x, which is 2, right? By this, you add h to the h, which is 0. Okay, and this on the limit of g of x, which is 5, right? So your final answer should be 5, 4 and 5. Sorry. Yeah, so this is your final answer. Okay. So let's move on. Let's move on. Let's move on. We are making some progress. Um, wow. I think we are. Oh, okay. We're not done. Oh, this is a lot. Okay. Okay. So we've already done this. And so yes, let me see. Okay. So there is a question that it looks quite simple. It looks quite simple. So now they can ask you a simple question, like the limit with x. Okay. So now, if you have a pen and a paper with you, I want you to try this question right now. Just in 2 minutes. Okay, then we'll continue. The limit as x approaches 9, right? Of root of x minus 3 on x minus 9. Okay. So you can try this question so that we continue later. Just quickly. Okay. There is something that there's something that I want you to take note of. So just 2 minutes, okay. So just try your hands on this, then we continue. Let me solve my thing. So now, when you have been asked to find limits, I don't know the number of you that have seen the trend actually, but
Sir, please, is the answer 1/6?
okay, let's solve it and see. That's a good try, but let's solve it and see. Okay, let's solve it. So when you're asked to solve the limit, okay, there is something that you have to look out for. Okay, now one is either you are rationalizing, okay, you are rationalizing something. Okay, two, which one again actually? It's either you are. Oh, I think I wrote them down. Yes, it's either you are factorizing something. Okay. So let me show you the. I didn't just choose these questions. Look at a question this, like this, right? How can you solve something like this? Okay. So you can try your hands on this
And Shoki.
and see
No,
how
no, not at all.
you go about. I want you to just think like how will you solve a question like this? If it was actually given in a question, just think this. Okay. So after then I come back, then we continue. Okay. So just try your hands on this, then we continue. Just this question, okay. If you can also solve this and get your answer, you can try it. You can do so. Then I want you to try it, okay, so that the consent as I come as we move along the way, we can address them together. So just from this, please try your answer on this question. Then we continue.
Please, what question do you want us to try?
This question, all the two, any of them. If you can solve both, that's fine. Yes, but this question. Okay, so let's try let's try on some. I want us to be done by 8:30. Okay, so let's try and solve this. Yeah, just so as I said, if you are being asked to solve limits, okay, what you are doing is that you're actually rationalizing or you are factorizing. Okay. So now with this, okay, it's clear that when we put in 9, we get 0 and 0, which is independent. We can't have anything like 0 and 0. So now how can we manipulate this so that we don't get a numerator of 0 and a denominator too of 0? Now, the best way to do so is to get rid of the set. Okay. Now, how can you get rid of the set? You have to multiply by the conjugate. So x plus 3. I shared a book and I named the book and Dr. Ben recommended book, and I think I added integration. Okay. That book actually has 1001 questions on limits, differentiation, and integration. I've said it over and over, and I don't think a lot of people still use it. But please, if you have that book, just go over it. It's a really good book. Okay. So as I said, this kind of questions you have to get rid of the set. Okay. By multiplying by the conjugate. When you multiply this, you get root of x squared, right? Which is x minus 9. Okay. On the denominator, right? X minus 9, right? Being multiplied by root of x plus 3. Okay. Of course, you can cancel out your 9. The limit as x approaches 9 of 1 on the root of x plus 3. Okay. So you can just insert this in as you said, 1 on 6. Okay. So quite simple. Okay. So the second one also, let's solve it quickly. Um, something like this. Okay. It's a similar concept actually. Okay. So you have to multiply this by the conjugate. Okay. So when you do so, you get the root of x squared plus 2x minus of x squared minus 2x. Okay. On let me on 1. Okay. Multiplying by the conjugate, which is x squared plus 2x, right? Plus conjugate. Okay. X squared minus 2x. So this is actually what's changing. Okay. This actually what's changing. The conjugate. So if you have an x plus something, you just change what's in between. Okay. So this also becomes x squared plus 2x plus x squared minus 2x. Okay. So you can just manipulate the solve this. Okay. And also give answer. I'm not going to tell you the answer. You just come to my game and solve it. They will not bring the same questions you are solving. Okay. So now I would like you to now the last question that we'll be solving is this question. Okay. I wish we do more, but you know, um I've done a lot of videos. Please watch them, and if you like them, just subscribe. Okay. YouTube is not paying me anything. So like 2 years. So so let's solve this question. So the question says that show that right now this question here, I would like everyone. Let me see the number of people in the class. I would like everyone, right, to just even if you won't solve it, right, just think about it. Okay. This that they will not ask you direct questions in math exam. I think most of you are familiar with it now. And let me just check this in. The math department shows it's actually a very principled department. If you see you are feeling, you can see it from afar. Don't expect that the marks will be added or something. In level 100, I was thinking that oh, they will add marks so that they'll push us forward or something. I don't know if they did, but please, no, the math department is actually a very principled. You can see your face from the beginning. If you see that you are not doing well, just pick up, go to the lecturers. You can come to my game. How can I study math? Like I've been trying, it's not working. I've been sharing some study tips, but I can help you do so to the maximum ability I can. Okay. So this is a typical examination question. Okay. I've had this question since level 100, and I am expecting that a question like this will come. Okay. Now, the question states that show that f of x is equal to 2x minus 1 on x minus 3 is continuous or discontinuous on the open interval of negative to 2. Okay. So now just take a minute, okay, and think about this question. Just think about if you are able to solve this question, congratulations to you because this is a typical examination question.
Excuse me, sir.
Yeah, hello.
Sorry, please, is it closed at -2 or opened at -2 or 2? All right, thank you.
I see it now. Um, hello.
Yes, please.
Okay, so what was your question, please?
I was asking whether it was opened interval or closed.
On the open interval.
Hello, sir.
All right,
Sorry,
thank you.
on a closed interval rather. Sorry. On a closed interval.
Closed interval.
Yes. On a
Hello,
closed interval.
sir.
Sorry, yes, it's supposed to be the other.
Thank you.
Yes.
Hello, sir.
Yeah. Yeah. Hello.
Please.
Sorry, let me just 1 minute. So I have to change this to close. Okay. I have to change this to close. Okay. Yeah. So please ask your question.
All right, sir. Good evening. Please, I want to find out that will you substitute?
What do you mean, please?
Please, I want to find out that will you substitute the -2 first before coming to use the 2?
Okay,
Or you are
that's
supposed to substitute -2 and and 2 added down.
do you have to, no. Okay, that's a good priority, but no
So I'm supposed to go with -2 first.
you go with the both of them. You go with both of them. But
I'm supposed to go with both of them.
and don't worry, I'll show you how to. So let me explain the concept, okay? Then after I'll let one of you try and explain how to solve it, okay?
Okay,
Now
please, I can't hear you. It seems like your line is breaking.
my line is breaking. Oh,
Yes,
sorry.
please.
Let me try and move out. So let me try and move out. Let me try and move my desk. Can you hear me now? Hello, everyone. Can you hear me? Hello, can you
Yes,
hear me?
it's
It's better now.
okay.
Okay. Okay, so let me quickly explain the concept, then we continue. So my tablet is installed. Just 1 minute, please. Okay. Now, as I said, there's a mistake here, right? So it's supposed to be closed. Now, for a function to be continuous on a closed interval, right? On a closed interval. So if you can hear me, just let me know, okay, so that I explain it better. So on a closed interval, -2, right? On this closed interval, right? Okay, so now think about it. You are having a line, right? From negative to to 2. Okay. And how can it be closed? How can it be continuous on this closed interval? Now, it should be continuous in between -2 and 2. It should be continuous at -2, and it should also be continuous at 2. Please hope you are getting the what I'm trying to draw. So I'm trying to make you visualize what you are doing right now. Okay? I'm not here to give you answers, but let you know something. Okay. So now I stated 3 conditions. Okay. It's supposed to be continuous in between -2 and 2, right? It's supposed to be continuous at 2, and it's also supposed to continue at -2. Now, from what we've learned earlier, right? How can we show that the function is continuous on the this thing confuses me often. I think this one is the open interval, right? Yes, this one is the open interval. So how can we show that the function is continuous on the open interval? Yes, how can we show this? So we have to show that the function is continuous on the open interval. Now, to show that the function is continuous at the open interval, right? It's actually quite simple. Okay, it's actually quite simple. So what you do is that you how should I put it? So now this is the function f of x, right? Is equal to 2x minus 1 on x minus 3. My roommate is telling me that you have to sketch the function, but unfortunately, you will not have the time to sketch the function. And if you sketch the function, they might be wrong. You might be wrong because you're not being asked to sketch the function. So thank you very much, my roommate. So now what you have to do is that you have to show that, right? So now all you are doing is that how should I want to put this in a way that it makes sense. Okay. So let me explain this way. Now the function should be continuous in between -2 and 2. Now you are having this function, and from this you can clearly see that the function is discontinuous when x is equal to 3. Please hope you all get me up to this point, because at x is equal to 3, the function is undefined. Right? Now we can see that x being equal to 3 is not in the defined interval. Do you get it? So because the value of x, which makes it undefined, is not in your open interval, you can conclude that the function is continuous on this open interval -2, 2. Okay, so now you are done with the first step, which is that you've shown that the function is continuous in between -2 and 2. Now, how did we do that? We show that the function is continuous everywhere in between -2 and 2, right? We found the value which makes the function discontinuous. How did we do that? We equated the denominator to 0, right? And because when the denominator is equal to 0, the function is undefined, right? So we got the value which makes the denominator equal to 0, which is x is equal to 3. Now, x being equal to 3 is not in our interval -2 and 2. Therefore, in this interval -2 and 2, the function is continuous. This is the first thing that we've done. Now we have to show that the function is continuous at x is equal to -2. That's the second thing we are doing. Now, how can we show that the function is continuous at x is equal to -2? It's quite simple. We go back to the laws, right? F of -2, right, should be equal to the limit as x approaches -2, okay, of f of x, right? This should be equal, right? These two should be equal. Now, to find f of -2, it's fala, you get it. You just put in your value. So 2 times negative, 2 times 2 minus 1 on 2 minus 3. Okay. This should give you, let me see, on 2. If I'm wrong, I think it should give you -1. -1. So
Say please
4 minus
again is -2 or 2.
So wait, let's do it together. So it's supposed to be negative rather, negative rather. So negative 4 minus 1 gives us negative 5. What am I doing? Yes. So yes. So we made a mistake here also. Yes. So negative 4 minus 1 gives us negative 5, right? On negative 5. And this gives us, of course, negative 5 on negative 5, which is equal to 1. Okay. So now we find a limit as x approaches to the limit as x approaches negative 2, right? From the left, negative 2 from the left, right? Of these two, x minus 1 on x minus 3, right? And when we do that, okay, all we have to do is to put in the value negative 2, okay? So when you do that, you are going to get 1. And of course, the positive 2 also, you are going to get 1, okay? Then you conclude that at the negative 2 over here, f is continuous because you've shown that the value of the function at that point is equal to the limit of f of x as x approaches that point. All I'm saying, Beyblade, is that f of a should be equal to the limit as x approaches a of f of x. So that's what we just did over here. So the f of a1, right, is we just did f of negative 2, right? You see, and we just found the limit of f of x as x approaches a, which is this thing we did over here. We found the left hand limit and right hand limit. We saw that they were equal. So that value that they go, which makes them equal, which is the 1, is equal to this limit. Okay. Now you can also do so for the second one, and I think that one also should be something like what are the limits of this? You get negative 3. Okay. So you get negative 3. You do your checks at negative 2, at 2. Okay. If they are equal, okay, then you conclude that on the closed interval negative 2 and 2, the function is continuous. Please hope you all get me, please. This was one of the questions that I've been expecting to appear in exam. It didn't come in a year, so I'm praying it from your year. That's why I'm taking you guys through. But please, any questions, please, because you if there are no questions,
Hello.
you close my yeah, hello.
Please go over again. Since the network was
Okay.
breaking, so some of us didn't get it well.
Sure. No problem. I'll go over it
Yes,
again.
sir.
I
Please,
asked in my
please,
yes,
please, f of 2 will not.
yeah, yeah, f of 2 will not give us f of 2.
So f of 2 will get negative
F of 2
f3.
1.
yeah, you get negative 3. What did I say? I said 3. Oh, sorry. Yeah, it's negative 3. Thank you very much. Thank you very much, Vicky. Thank you very much. But please, okay, so I'll go over the steps again. But please, do you all get the concept I'm trying to raise over here? Do you all get the concept? Hello.
Say yes.
I'll go over
Yes,
it
have
the
a
last time. Yeah, please ask all your questions, okay? Because I want to go over it again. I want to
So
take it
when you're done finding for the closed interval of -2 and 2, are you not supposed to also check for the in for the range in between the -2 and 2? For example,
yeah,
using a variable of c,
using the I didn't get that first.
using a
Using
variable
the
of
what?
c to represent the
No, no,
open
no,
interval between -2 and 2.
no. You don't use. Okay, so what you are doing? No, you don't use variables to check. See, there are infinite values in between negative 2 and 2. So if you use a variable, let's say 0, and somebody uses 0.1, and it's not defined as 0.1, then do you get what I'm
No,
saying?
I'm saying a
That
variable of c. For example, c, the letter.
C.
So the c is standing in
Okay.
for the numbers.
Okay. The number as which is undefined. Yeah. So we did that earlier, even
Yes,
before we
yes.
started solving. So as I okay. So let me explain like everything again. And when I reach your point, I'll come back with it. So now we are saying
All
that
right.
so that the limit is continuous, right? On the closed interval negative 2 and 2. Now, I
I
started
thought
by
that
saying
one
that it's
was
not
for
continuous.
IBT.
What I'm doing right now. Or okay, let me finish explaining. Then you come in with your question. Okay. Yes. So how should I answer? Um, so for the function to be continuous from okay, so what this means is that it's from -2 right to 2. I have a video on intervals. You go please go and watch and subscribe. Okay. So it's supposed to be continuous from -2 to 2. Okay. Now for it to be continuous from -2 to 2, okay, good. It has to be continuous in between -2 and 2. Okay. That's the first one. It has to be continuous at -2. And also it has to be continuous at 2. Okay. These are the three things that we are coming to do. Okay. Now, this is the function that you have. Now, what we are going to do is that we can input in like values in between -2 and 2 and test for the values that make it continuous. Do you get it? So you can't put in 1 to test, 1.1 to test. So the better way for us to check the values that make it to check whether every value in between your interval -2 and 2 is continuous is that you find a value that makes it discontinuous. Okay. Now, from the function, we could tell that okay, so we know that for all functions, when the denominator is equal to 0, right? The function is undefined because you get something like 5 on 0 or x on 0, right? And something like this makes it undefined. Okay. So we can say that okay, let's equate our denominator to be equal to 0. So when the denominator is equal to 0, right? X is equal to 3. Okay. So when you equate this to be 0, right? So this was okay. How the 3 came in. Yes. So if you equate your denominator to 0, right? You get x is equal to 3. Now we know that at x is equal to 0, at x is equal to 3, right? The function is undefined. Now we were given an interval -2 to -2 to 2, right? Now the function, the value x, which makes the function undefined, cannot be found in that interval. So because it can't be found in that interval, that means that every value in between -2 and 2 is defined. Please, do you get me? So by so so when you find out x, right, you can conclude that okay, let me this study a little. So because the value x, which makes it undefined 3, is not in this interval since it's somewhere over here, every value in between -2 and 2 is defined. We are done with the first one. Now you have to show that the function is defined, right? At x is equal to -2 and x is equal to 2. We all know that these two conditions must be satisfied. Okay. The function at x is equal to -2, we just put in the value, right? And we get 1. And we also find a limit, okay, as x approaches -2, right? We find a left hand limit and the right hand limit. We want over that. And for the -2, we got 1. And for the +2, I think we got -3. Okay, so please do get me. Hope you get me, please. Hello, everyone. Please, do you get me?
Yes, sir.
Okay, so
Yes,
thank you
please.
very much for taking my class. Okay, so let's
Yes,
pray
sir.
then. So, Father, we thank you for this opportunity to study. We say a prayer that you guide and protect us and that you grant us retentive memory to remember all we've learned. Guide us and be with us, O Lord. In the name of Jesus, name we pray with thanksgiving. Amen. So please go and write your I. When is your 1 to 6 IE, please? When is your 1 to
The
6
next week.
IE? Next week. Wow, wow. So you have time to prepare actually. So if you have any
Sir,
question, okay,
sir,
after
please
that, yes.
question.
Please, I'm not a sale. I'm a level 200. So those of you who join with your ID and your name, I beg, don't join with ID anymore. I'm just a level 200.
Okay, please, can I ask a question?
Oh yeah, you can ask the question.
Please, since when we plugged, since the function will be defined on an opening interval -2 what? So it means it's continuous, right? So does that mean that we've answered the question?
Yes, because I've stopped sharing. Let me share again. Yes, because the question was that you are to show that it is continuous on the closed
Interval.
interval. Right? Yes.
Yeah.
So now you first found that it's continuous in between,
Yes, please.
and you also found that it's continuous at the size -2 and 2. Okay.
Oh.
So I'll try and get the recording. I don't know the way Teams does it. I'll try and get the recording. And if I wake up early, I'll upload it on YouTube because I don't have data to upload a 1 hour 43 minutes. Wow, we did a lot of video. Okay. So so if
That's fine.
I said that if you have any questions, you can come into my DM and ask. Just I won't give you the solution. Okay. I have solve all the questions. So I'll just explain it for you. Okay? So if or
Please,
put it
how
in the
can I
group
join the
so that when I explain it, everyone can get access to the question. Yes, please.
how can I join the group?
You are not okay. So let me share my group link into the chat. Then you can. Then I think so. So those who are
Please
not in
add
my
your
group, let me
YouTube
share
handle.
my YouTube handle, or you can search it
Please
on
add your YouTube handle.
my YouTube handle. You can search me. You can search on YouTube. You'll get it. Okay. So teach me maths. That's the name of the channel. Okay. Or you can join the group. I'll send it to you. Let me add it in there.
Say,
Yes, please.
say, did I hear that you said you were in level 2 and
Yes, I'm in level 200.
oh, okay, nice.
I
Yes.
am.
Please,
I am
which course?
in level. I'm going to say.
Yeah,
Which
please,
one?
which course?
Which what?
The course you are reading.
I'm I'm a single major computer science student.
Nice. Awesome.
So I've shared the link to the in the chat section. Okay, so you can just join the group if you haven't. Share your study groups. Like I don't just teach. Okay, I teach you how to pass. You don't have to learn plenty to pass. Like no. So but learn. Okay, but so join the group. Okay, if you have any challenge, you can just come to my DM. Okay, then we talk. Okay. So
Okay,
thank you
thank you,
very
sir.
much. You're welcome. Thank you very much. And the guy who was answering so many questions, helping me out. Please come into my DM. Okay, I want to talk to you. Okay, thank you very much for helping me out. Yes. And with
Hello,
Auntie
sir.
Anne.
Hello, please.
Yeah, hello. Yeah,
Yeah,
hello.
please. Is it possible to get all the questions?
Pardon me, please.
Yeah, I said, is it possible to get all the questions?
Yeah, I've sent the questions to my channel. Well, let me see if I can share them in the chat right now. Okay.
Okay.
So I'll share the question. Okay, let me try and share it right now to the chat so that everyone can get access to them. So
Okay, thank you, sir.
I'm trying to do right now.
Okay.
So I can't share a file over Teams. This one. So you can join my group. Then I share it to you later. Okay. Please are these the questions for the please tomorrow? Please be particular of the steps. Okay. There's one concern that I'm stressing on. Be particular of the steps. After go for your IE papers, I'll explain why later. Okay. But thank you all for joining. Bye.
Okay, thank you, sir.
Please, I have a question. Hello. Please, I have a question.
Yeah, what's it?
I have a question about the book you mentioned that you sent to some students and it has some limit in it. I would like to know the kind of the kind of book that is, or the name, so that I can get it and study it. Hello, Dr. Ben.
I think he's out too.
I think, yeah, he left. DM him on WhatsApp to ask a question.
Okay, sure. Thanks.
Am I